Newton's third law, as originally stated by Newton, says, "To every action there is always opposed an equal reaction," or "the mutual actions of two bodies upon each other are always equal and directed to contrary parts." So that's the complicated and maybe convoluted language that Newton chose, including convoluted, perhaps, punctuation that Newton chose to use. I have a statement here that maybe is a little bit more modern, maybe has a little bit of my own interpretation thrown into it, but it says forces represent interaction between pairs of objects. So in other words, anytime there's a force, there's got to be a pair of objects interacting. You don't just get a force if there's no other object like pushing on whatever or pulling on whatever other object is receiving that force. For an interaction of a particular type, the forces exchanged are equal and opposite. So, for example, if I said, hey, let's look at maybe like two like planetary bodies that are maybe far from each other, or maybe it's like Earth and its moon or something like that. We know that the force of gravity is a type of interaction between these two objects. And in that sense, from a Newton's forces point of view, if there's a gravitational pull on this object, and if this larger object here that I've drawn, to this object over here, that represents an interaction between the two. And what Newton's third law is saying is, if you ask, like, what would be the force on the second object? Well, it has to point in the opposite direction. And not only that, it has to be the same magnitude. And that can sometimes be a little bit like intuition defying that these two should be the same magnitude. I don't know if I drew them exactly the same magnitude there. Because a lot of times our intuition will say, well, surely the bigger object should pull harder on the smaller object, right? Or like, like if I have two objects that collide with each other, maybe the bigger object applies a harder force on the smaller object. But what Newton's third law is saying, for any type of interaction, the force pairs exchanged between the two objects involved in the interaction will always have equal magnitude, and they'll be directed in exactly opposite directions.